Hello and welcome back to class. In this video we'll be looking at tangents to a circle, still under circle geometry. We want to consider a tangent to a circle, but before we do that, we want to identify what a tangent is. Now when we say a tangent, what do we mean by a tangent? A tangent is simply a line, a straight line which is drawn that touches just a part of the circumference of a circle. So in other words, what that means is that if we have a circle like this, a tangent to this circle will be a line that is drawn, a straight line which just touches part of that circle. So if we have line AB becomes a tangent to this circle. Let's call circle O. This circle has O at the center, so this line AB becomes a tangent to the circle O. So the tangent does not pass through the circle, no. It just touches a part of the circumference, and that is what makes the tangent. Alright, so we are looking at tangents to a circle. Now let's consider part of the theorem that we have for tangents of a circle. We've identified what a tangent is. So let's look at one of the theorems that we have under tangents to circle. The first theorem that we have is this, that a tangent to a circle is perpendicular to the radius drawn to its point of contact. That is the theorem 1, that a tangent to a circle is perpendicular to the radius drawn to its point of contact. What does that mean? We are having a keyword here, perpendicular. A tangent to a circle is perpendicular to the radius. So a tangent is perpendicular to the radius drawn to its point of contact. Let's make a diagram to illustrate that. So what it is saying is that if we have a circle and we have a tangent, let me change the color for tangent now. We have a tangent, okay. So we have a circle, and then we are having a tangent. Remember that tangent just touches the circle. So the theorem is saying that this tangent is perpendicular to the radius, and the radius is a line drawn from the center of a circle. So if the circle has a center at O here, so the radius is any line that is drawn from the center to any point on the circumference of the circle. But in this case, the theorem states that a tangent to a circle is perpendicular to the radius drawn to its point of contact. So from here, the center will draw a radius down to the point of contact. So the law is saying that the tangent, in this case, if we call it A, B, C, the tangent ABC is perpendicular to this radius, and when two lines are perpendicular, it means that an angle of 90 degrees is formed in between them. In other words, there is a 90-degree angle formed here. That is what we can make out of this theorem, that a tangent to a circle is perpendicular to the radius drawn to its point of contact. So we have a tangent ABC and we have a radius R. At the point of contact, which happens to be here, they are perpendicular, and that means that an angle of 90 degrees is formed there. That is what the theorem is saying. So if we want to solve an example to illustrate this, let's solve an example. Let's say that we have a circle, and then we're having a tangent. Okay, just like this, a tangent, and then this circle is having a center at this point. We have a radius drawn to the point of contact, and then if we should extend this to have a triangle formed, if we should extend this properly to have a triangle formed, maybe we have been given the value here as 70 degrees, and we have to find the value of the theta here. How are we to do that? We're looking for the value of the theta here, the angle, the value of the theta at this point. Now, when we remember the theorem that we just looked at, that when you remember, this is a tangent. This line here is a tangent to this circle. All right, and what that means is that again, this line here is also a radius. So we're having a tangent here, we're having a radius here, and the theorem states that they are perpendicular, and when they're perpendicular, it means that there is a 90 degrees formed in between them. In other words, we can look at this triangle, can bring out this triangle. Here is 90 degrees, here is 70. We can easily find what here is, because sum of angles in a triangle must give us 180 degrees. So it means that 90 degrees plus 70 degrees plus theta must give us 180 degrees. That's sum of angles in a triangle. Now 90 plus 70, that would give us 160. So we're having that theta plus 160 is equal to 180 degrees, and of course theta is equal to 180 minus 160 degrees, and that will give us the value of our theta to be equal to 20 degrees. We have 20 degrees. So that's one way we can look at this. Another example, let's also look at another example. Let's say that we have a circle here, and we are having a tangent. Let me use another color. Let's say that we're having a tangent. Let's say we're having a tangent to this circle, having a center at this point. All right. We'll have a radius drawn to this point. We'll have something like this. Okay, we'll have something like this. Now, assuming that we have been given the value of here to be 72 degrees. Assuming that we have it to be 72 degrees, and then we are asked to find the value of here, the value of the angle here. Let's call it A. We are expected to find the value of A. How are we to do that? How are we to do this? All right. Now, in solving this, remember that this line here is a radius, and this one here is a tangent. So that means that they are perpendicular. So it means that the whole of from here all the way down to this point is 90 degrees. That's what it is, because here and to down to this point is 90 degrees. Okay, so ordinarily it will mean that our A plus 72 must give us 90 degrees, because the value from here to here is 90. So our A, which we're looking for, plus 72 must give us 90 degrees, and that means that A is equal to 90 minus 72 degrees. 90 degrees minus 72, that means that our A, so it means that our A is equal to 90 minus 72, and that will give us 18 degrees. That will give us 18 degrees, and that is what we're looking for. Therefore, in this case, the value of A becomes 18 degrees. When you add up your 18 degrees plus 72 degrees, that will give you 90 degrees, which normally would be the value from here to here, because this radius here is perpendicular to the tangent that we have here. Remember that perpendicularity indicates that there is a right angle between the perpendicular lines. So that's another example, and there are other ways that we can see questions that border on the theorem of perpendicularity of a tangent to a radius of a circle. Okay, so that's that. In our next video, we'll be looking at tangents coming from an external point. We'll be looking at tangents from external points to a circle. We want to look at the theorem around that. When you have two tangents from an external point to a circle, we want to look at the theorem around that. So until the next class, I'll be seeing you. Bye.